What's up, friends? So, oh man, I should have got more water. My stream's kind of been exploding today. From all of my classes, something has gone wrong. So I would say expect something to go wrong in this one as well. 2 minutes late. I know I couldn't get it to start. So at least once, I think per class, my audio has cut out. So definitely be on the lookout for that. If at some point, just type in the chat, you got a fresh cut. No, I haven't had a haircut since spring break. If you're just trying to compliment my hair, though, I appreciate it, but no, I didn't get it cut. Let me see it from the side. No. But anyways, yeah, just let me know if something's going wrong or cuts out or whatever. I've had to restart the stream a couple times. Yep. Okay. Whew. Last class of the day, for me at least. So let's get this done. So for the warm-up, find the vertices, co-vertices, and foci, and then graph. All right, so this is an ellipse, like we left off with talking about yesterday. And let's start with the center, since it's kind of the easiest thing to find, which would just be 1, 4. And we get that from the h and k here. From there, let's look at what the vertices would be. So I first need to figure out which is a squared. So remember that a squared is always the larger of the two denominators. So in this case, that means it must be 64. Which means that a is 8. I should now also be able to automatically tell this is a horizontal ellipse, right? Since the larger number is underneath the x value, then I know the ellipse will be larger in the x direction, so wider. So let me put my graphic. So 1, 4. So here's that center. And then for the vertices, so since this is a horizontal ellipse, then the vertices will be on the left and right side, that widest side. So I'm going to go to the right 8. 1, 2, 3, 4, 5, 6, 7, 8. So I'm 1 off the graph. That's okay. And 1, 2, 3, 4, 5, 6, 7, 8. So to the left 8 as well. So I can figure out my points are -7, 4, and 9, 4. Those are the vertices. So let's move on to the co-vertices, which will be the shorter on the minor axis, right? So above and below the center, since it's a horizontal ellipse. Co-vertices are based off of b squared. So b squared is the smaller of the denominators, which in this case is 16. So the value of b is 4. So if I start at the center, the co-vertices should be up 4, 1, 2, 3, 4, and down 4, 1, 2, 3, 4. So those actual points would be 1, 8, and 1, 0. Those are the co-vertices. And this should be what my kind of the skeleton of my ellipse looks like right now. Now I move on to the best part. Right? I know it's Megan's favorite part, is actually drawing the ellipse, which is, kind of tough. Let's see how it goes. Okay, not a bad start. Let's see if we can bring it home with the bottom half. You know what? It's serviceable. No. You just got to draw it. And there you go. 7 out of 10. I'll take it. For AP, 7 out of 10, that's a pass on the PFA. So I'm on board. Yeah, I know it's a fail. I said for AP. This is not AP, but I'm an AP teacher, so I think it applies to me differently, Right, yeah, and I'm talking about AP art. Since I'm the AP art teacher, then any artistic skills that I do only requires 7 out of 10. So I win. All right, and the last part, let's find the foci. Use the pink pen. Like this one. Green is not cute. Wow. Okay, so for the foci, that's based off of C. So how do we know what C is? Well, it's a squared minus b squared. So in this case, 64 minus 16, right? Yes. 64 minus 16. So 48. I think that's right. And then square root of 48. That was just a really weird sound. What was I talking about? Oh. So 48, what is it? That'd be 16 times 3, right? Doesn't that work? Yeah, so square root of 48 I can think of as square root of 16 times square root of 3. So that's 4 root 3. Of course you like pink, Megan. But everyone knows my favorite color, right? After all this time, you guys have learned this information about me, right? Right? So my foci will go along the major axis. So for this horizontal ellipse, it'll go left and right. So the center started at 1, right? So 1 plus or minus 4 root 3. 4. Purple. I knew my trusted student Cassidy would know my favorite color. Why do you always say this, Megan? I'm always the type of person to do everything according to you. Cassidy is very trusted by me, not by her parents, but I trust Cassidy at least. So 1 plus 4 root 3, that's almost 8. It's like 7.9. So there's 1 foci and then 1 minus 4 root 3. Negative 5.9, so almost negative 6. So there's my 2 foci. Not trusted by Mrs. Lee. I have no comments about that, you know. MJ, you don't trust Cassidy? That's a shame. That is a shame. Now you won't get to use her iPad. Okay. So center, vertices, co-vertices, and foci. All right. So let's finish off our ellipse stuff today. It shouldn't take us too terribly long. At least the actual math talk. But who knows what else we'll rant about. So putting the ellipse into standard form, let's do almost the same process of what we did before with putting circles into standard form. Okay. Our first step is going to be to take the constant, move it over, and I'm going to group x's and group the y's. So x squared minus 8x, I'm going to leave some space, plus, well, actually, I guess I won't do it yet, plus 5y squared minus 30y equals 39. Okay, so group the x's, group the y's, move the constant over. Now, for circles, what we did at this part was we would just complete the square, but we don't want to complete the square yet, okay, because the difference is the y squared has this coefficient of 5. Now, the x squared does not. X squared, the coefficient is just 1. But since there is a coefficient on the y squared, we need to factor that out. We need to factor out 5. All right, so here's what I'm going to do. I'm going to leave my x squared stuff the same. Now I'll leave some space. Plus 5, but I'm going to factor that out. So y squared minus 6y equals 39. So I just factored out the 5 from the 5y squared and then minus 30y. Now we can complete the square. So remember, completing the square is we add b over 2 squared to both sides. So negative 8 over 2 is negative 4. Negative 4 squared is 16. So I'm going to add 16 over here. And when I do b over 2 squared over here, so negative 6 over 2 is negative 3. Negative 3 squared is 9. So plus 9. But now here's where people go wrong. I do not just want to add 9 here. Okay, that would be wrong. Because we have to look at what actually is happening. On the left side of the equation, it's not that we're just adding 9, because that 9 is inside of parentheses. And then on the outside of that parentheses, it's getting multiplied by 5. Okay, so actually what I need to add is 45. Because if I distributed, then on the left side I would have a 45. But on the right side, so I don't want to just add the 9 on the right side. I'm adding 9 times 5. Wow, surprise, surprise, you guys, that Megan is talking about serial killers again. Where have I heard this before? So strange that she would just bring it up out of nowhere. Now we can factor. So x minus 4 squared y minus 3 squared equals 39 plus 16 plus 45, a cool 100. And so now we're at another slightly different step than before. From circles, we would have just stopped here. But we have this coefficient of 5 still. And since we know this is an ellipse, then the right side should just be 1. Right? In the equation of ellipse, like in our warm-up, the right side of the equation is just 1. So if we're trying to make that right side of the equation 1, all we need to do is take everything and divide it by 100. Okay, so 100 divided by 100 is 1. X minus 4 squared over 100 plus 5 over 100. So that would simplify into 1 over 20. So here's my standard form version of the ellipse. This is so much more useful to us because when we look at this, we can determine what the center is. We can determine what the vertices, the co-vertices, etc., and the foci. Still our same process of completing the square, but there's a little bit of an added issue because we might have some coefficients that we need to factor out. And so that'll change how we add things to both sides and what we do. All right, let's go for our next one. So same thing, just putting the ellipse into standard form. Same starting steps. Move the constant over, group x's, group y's. So 4x squared minus 48x plus 9y squared plus 72y equals negative 144. Okay, now, like I mentioned on the last one, we have this coefficient in front of the x squared and it's in front of the y squared in this case. So before I move on, before I do any type of completing the square, I first need to factor out that 4 and factor out that 9. Okay, so I'm going to do that. So 4 to be x squared minus 12x, and I'm going to leave some space so that I can complete the square. Factor out the 9 for the y's, so y squared plus 8y. And then on the left side, minus 144. Okay, so whenever we see a coefficient either in front of the x squared or in front of the y squared, we have to factor those out first. You're upside down. What do you mean? Upside down. No, thank you for typing upside down again. It wasn't a problem with reading those words. You and the notes. Okay. I think this is helpful. Okay. Let's do the old flipperoonie. That's what I call it. Okay. Ah. Okay, so this is flip. This will flip. I'm gonna go back. Okay, that should be good. All right. So we factored out the 4. We factored out the 9. So now I'm going to complete the square for both. Complete it for the x, complete it for the y's. Negative 12 over 2 is negative 6. Negative 6 squared is 36. Now completing for the y's, 8 over 2 is 4. 4 squared is 16. And like I said in the last one, it's not that we want to just add 36 and add 16 to both sides now. Then we need to actually think about this 36 is getting multiplied by 4. And this 16 is getting multiplied by 9. So on the right side, I'm going to add 4 times 16. Or no, sorry, 4 times 36. And add 9 times 16. So not just the 16, not just the 36, but the coefficients times that as well. I can't see the notes. They are too little. I'm not listening. It's like the little line of an eye exam. Shake my head. Are we sure he's not playing an April Fool's joke on us? Because this is pretty good. Is it what? My birthday is in 19... What? Okay, hold on. That part can't be important. I think I missed something back here. Austria. No, too far. Upside down. Now the notes are little. What? Now your face is big and the notes are small. The notes are in the top corner instead of you. I can't see the notes. They're too little. Oh, I already read that part. SMH my head, man. Your notes are now where your face cam should be. Oh. Okay, wait. Oh, so now I'm the main screen. Is that what you're saying? And like the notes are like right here or something? Or I don't know which corner. It's mirrored, right? One of these corners or this corner. Oh, okay. Okay. But it is right side up, right? We're not upside down anymore? My upper left. Left. This? Oh, right side up. Okay, well, beggars can't be choosers, you guys, all right? As long as we're right side up, I think that this should be good enough for us. Isn't this better anyways? Isn't it more useful if I'm like the main, source of the stream? That's just too much of my face. What? Well, do I need to put the mask back on? Okay, so what I'm hearing is if I put the mask on, then this setup is still fine. So yes, I'll still be the big part of the screen, but I'll just have a mask on. And then the notes will be still here or whatever. Or no, wait, left. You said left. Here. Exactly. The mask is the answer. I think we all agree on that. Precisely. Okay. All right, all right. Let me add this in. Okay. All right. So my screen is little again. Well, hold on. I'm changing my settings currently, and then I'll click save in a second. So my screen is little. I'm in the top right corner. You're waiting for The Mask. I mean, yeah, The Mask is a great movie, but Jim Carrey just kind of fell off the deep end lately, you know? And then we'll do... Okay. Okay. All right, we're losing a lot of time here. I'm getting it. I got it. My screen, I got it. Okay, so we're losing a lot of time. Let's go. Let's go. So I'm going to factor each of these. So x squared minus 12x plus 36. So that's x minus 6 squared plus 9. And so I factor all the y stuff. Y squared plus 8y plus 16. So that's y plus 4 squared. And then on the right, oh gosh, negative 144. Hold on, let me get my calculator. Negative 144 plus 4 times 36 plus 9 times 16. Oh, positive 144. Neat. Okay. So positive 144, right? The Penguin movie. What the hell? What's the Penguin movie? He carried the Sonic movie, so never saw it. We can't see the notes at all now. I can see them. So wait, you can? Cassidy can see them. Just Cassidy? See Mr. Popper's Penguins. Oh, okay. Right. Mr. Popper's Penguins. That's classic. Instead of the notes, we see the class schedule and you and the mask. No, I don't have the mask on. It's on the floor. Why aren't you wearing the mask? It's just not conducive to speaking. I can't breathe in that thing. It's too hot unless I have the canisters in. Know the mask that you drew on yourself. I didn't draw that. The N19 mask. It's N95. We don't care. We want the mask. Listen. All right. We can all listen. I'll bring up the mask on the live stream later. Okay. And we can all watch it together. We'll have a movie night. Everyone eats popcorn. It'll be great. Okay? Is everyone okay with that? Popcorn movie night? I mean, it's a fan favorite, right? Everybody likes The Mask. Have you guys seen The Mask? Can you imagine not seeing the mask? I truly can't. That sounds like the worst. Okay, can we get this done now? I am not a boomer. Why would I watch that? That got me. That was good. You're just trying to learn. Well, I'm in teaching, and you guys keep yelling at me about whatever. It's too small. I can't see the lettering. It's upside down. Like, I don't know what you want from me. All right, we add 36 Hmm. Can you hear me now? No? Maybe? I'm back. But with audio or without audio? Cool. Okay, so just super quick. Um, eccentricity. So it's just an aspect of an ellipse. So we would just say, like, let's say, for example, if in the ellipse A is 3, and if we solved and found that C was, I don't know, 1, whatever. Okay, or, yeah, let's just say that. So then the eccentricity is 1/3. So we would just say the ellipse has an eccentricity of 1/3. Right? That's all it is. The closer to 1, then the thinner the ellipse will be. Okay, so something like this. Okay, a very thin ellipse would have a high eccentricity, closer to 1. And the closer to 0 that the eccentricity is the wide. Well, I guess not wider would be good. Let's say closer to being circular. Right, so maybe something that's like something like this, where it's definitely an ellipse. It's not a perfect circle, but it's closer to being more circular. Shorter. No, not shorter. Thickness. Sort of. Okay, so that, I guess that would be an example for a vertical ellipse. So a horizontal ellipse, if the eccentricity was closer to 1, then the thinner it is. I guess that wasn't a good example. Closer to 0, it's more circular, kind of like a. Said your word was inappropriate. Why? What'd you type? Nice. Okay, so that's eccentricity. You might encounter on a PFA that it asks you what is the eccentricity. So literally it's just you'll have to figure out what C is, and you have to figure out what A is, and then you just divide them. That's it.